Hi, my name's David, and today we're going to do another pair programming lead coding problem. I know that studying for coding reviews can be a pretty stressful, frustrating process. So I hope to show with these videos that can be fun and exciting. Today's guest, we have Javier. Javier, why don't you introduce yourself and say where you're from?
Hey guys, my name is Javier, a software developer from Venezuela, but I live here in the US. And as David said, coding challenges can be fun as well.
Awesome. And fun question. What's your least favorite part about coding
What's my least favorite part about coding?
or being a software engineer?
Hmm, you know, um, I would say my least favorite part is that you, as a software engineer, you always want to make cool stuff. And whenever you get into the field, you realize that cool stuffs take a long time to get developed.
Right. Yeah, you want to work on the most exciting stuff, but sometimes, yeah, you have to do it in steps or in
Yeah,
stuff, fix boring stuff that needs to be done.
a cool project can take you a month easily.
Right. Okay, Javier, why don't you share your screen? Great.
See my screen.
So today we're going to be doing number 434, number of segments in a string. And you're going to be solving this in JavaScript, right?
Right. Yeah.
Okay. So first, take your time, read the prompt, make sure you understand it, and then explain to us your understanding of the prompt using the two examples. Once you understand what's going on, begin coding. And finally, when we get a working solution, we'll go over the code and the time and space complexity. Does that make sense?
Yeah, makes sense.
All right, you may begin.
Okay. So it's a number of segments in the string. Given a string S, return the number of segments in the string. Segment is defined to be continuous sequence of non-space characters. So for the first example, we have, hello, my name is John. As we can see, it's actually determined like each segment will be determined by the space, but we can have special characters because we have this comma here, and it's they have it right here on the actual like explanation array. So we have to take care of those special characters. So well, the actual output is not the actual segments, but it's going to be the length of this segments array or the number of segments that we have in the string.
Right.
So as we can see in the second one, again, there's no there's no actual space, but again, since we have one word, no space, it takes it as one.
Right. So it's,
Yeah. Yep.
So I was going to say, yeah, it's a string. And then if there's a space that defines a segment and you want to count how many segments there are.
Right. Then we have our constraints, which the one that we really should care about is this 2 here, because it pretty much tells you that the special characters still count, that the only thing that would really break this segment would be a space, pretty much.
Right.
This is something that you really encounter yourself doing a lot of software engineering, breaking strings.
Yeah, parsing. Yeah, something. Yeah, do that. All right. So how do you think you can go about this?
The easiest solution, I think, just because I've used it, it's one of the things that I use constantly, is I can literally split and return the length. I can split my array, and I can just I can actually return it right away, since split is well, it's an array and string method as well. Really, actually, it's a string method in this case. Which is, you give it a separator, like you tell it where you're going to actually split on a string, and it's going to return an array out of it.
Okay, so
it
it
does
takes a
not
string,
modify.
it takes
Mhm.
a string and then it splits it into an array based on what you pass through, and you're passing through an empty space. Okay.
Right. Like literally, if we take, for example, example one, and we split it,
Mhm.
it's literally going to return as what they have in the explanation after you run split on it. Because what we want is the actual length of it. We would just return the length of that split array.
Okay.
Mhm. Well, yeah, I think this would actually work. Yeah. Yeah, if I run this, it should.
What if it's more than one space? Like
Right.
but like hello,
Uh,
comma, two spaces. Would that still get it?
in this case, split wouldn't get it. Now that you mentioned that. But you can also, again, like this is not the most solution, the most efficient solution, but you
Mhm.
can always again, like with another method, you can just filter anything that it's pretty much an empty string, and you would still get it. Again, now you would be literally going over the array twice, so it's definitely not efficient. But that would get it because
Okay.
empty spaces would still
So why don't
calculate this.
we run it
Mhm.
and see if this works for the first example?
Right. So like again, as I was mentioning, so once we split this, as you said, there could be cases where you have two spaces, three spaces,
Mhm.
or infinite amount of spaces. In this case, that if I am not wrong, I think I've run into that problem before, but I'm not sure. That would actually return an empty string inside of your
Mhm.
array. Which again, you can just, in this case, you can just filter, and
Okay.
then like in this case, you could say for every item in your array,
Mhm.
uh like if item pretty much the length, this is going to be like if item the length that is equals 0, then I mean it actually it's oh, oh not equals 0, greater than 0, then this would return true. And again, filter is another array method. Anything that returns true and the comparison that's happening in between would actually uh, be in the output for the next array. Like right here, if we grab the example here and we had, let's say that we had two spaces here,
Okay.
done, it says here. Uh, if I'm ground, this would return an empty array between these two. And then once we filter it, item, it's going to be for array methods, anything that you put here doesn't have to be item. It doesn't have to be in a specific name, like any variable name, pretty much
Yeah, you gave it the name item.
you give it. I give it the name item, but it's just going to be the item that I'm going to be iterating over, the element that I'm going to be iterating over. So once I get here and I double check that the length is actually not greater than 0, this will now be in
Yeah.
the output array.
So it's gonna ignore that.
Yeah, it's just
So
going to
yeah.
return an array without it.
Okay. So now you have
And
that, and what else you can do?
and then I would return the length of it, and that would work in this case, at
Nice.
least for that for that corner case in this case.
Okay.
That's for this one. Again, nothing more efficient then, because the split goes over the array once and then filter goes over the arrays once again. So this would actually be O(n) squared for this one, which is definitely not going to be super efficient. Yeah, but I think that this would take care of that, so that should
Yeah.
pass.
Yeah. Let's try it to See if it works first. Nice.
Okay. Could still submit it. Probably wouldn't pass because of the time, but yeah, I think it would pass. Yep. That's for this one. You want me to submit it? See
Yeah,
if
try
it passes
submitting it.
over?
Yeah, see if there's other test case. Nice.
Yeah, and actually, like the funny part is, it seems to be not efficient, but
it's beating a lot
it's beating a lot of people. Amazing.
Okay, so let's go over the time and space complexity. So the time complexity you're saying is O of n squared, right?
Mm-hmm.
Why?
So the time complexity is going to be O n squared because the split goes over the array once, and it returns it returns another array. It does not modify the first one.
Okay.
So on that end, we already know that we are creating another array. In this case, it's already O and space complexity as well.
Okay.
And then filter is going to do the same thing. We're not really storing this in memory, so it's just still going to be O. And if I'm not wrong, it's not going to be O of n squared, at least for the space complexity. But again, this filter would go over the array once again, so it's O n squared, because for each like every time, I mean, for each actually, you know what? The funny part, this is actually not O n squared. This is actually O n, because I iterate over the array 2 times.
Right.
But
so it's because it's going to be O of 2n, which rounds down to O of n.
Yeah. It's actually O of n.
Okay. Can you type that?
I did miss that.
so O of n, right? Because it's looping over the same array.
Right. Like this is actually O of 2n.
Yes.
But again, we get rid of constants in O notation, so big O notation, so it's O n still.
And then can you go over the space complexity again?
Sure. So for the space complexity, when both the split and filter do not modify the original array, they actually return a new
so you're creating a new array.
I'm creating a new copy. So again, we are not really after we split it, and the second one we filter it, we're not really storing this first one. This one is going to get cleared out, really, because we're not really storing it anywhere in memory, but then we use it in filter. So to my knowledge, it's still going to be O of n time complexity, really, because again, we are creating it once, and then we are going to filter.
Yeah, because you're creating a new array.
It's the same case scenario. It's technically going to be O to n, but again.
Okay, so O of n space complexity.
Yeah. O of
n
space complexity. Correct.
Nice. So you did that in a pretty good job. How did that feel? Easy?
Good. Yeah, easy and fun.
So let's challenge you. How can you solve this without using O of 1 space? So basically you can't split it.
Correct. Yeah. In this case, I wouldn't. If I'm going to do it in O of 1 space, I can't create any auxiliary like memory, really.
So you can create constant variables. Yeah. So go back to the script and you as a hint, you can create constant variables to solve this.
Right. So what I think is I mean, technically I could create a variable, just ones that is constant.
Yeah.
Really. So I can't create anything that creates like extra memory depending on the input.
Right.
So I guess I could create a counter, really. And every time that I encounter, like, pretty much I'm not going to count anything related to spaces, pretty much. Meaning what? I'm going to, let's say, for example, on this input string, I would go over age. Like once I start counting like once I have a character, I increment my count by by 1, and then once I reach in space, I stop. I won't count I won't count anymore.
Okay.
In both. In this case, if I encounter in the space, or if it is the length of the actual string.
Right.
I'm
Yeah,
not
because
gonna.
you can't go over the boundary.
Yeah. And then let's say that if we had 2 spaces here, then the space, I don't count it. Space again, I don't count it. I find a character, I count again. And
So when you
I
say you
still have
count, you create a variable count and you increment it.
I increment my variable count. I would have a counter here. That would of course start at 0 really, and then
And then when you increment it again?
then I'm gonna increment it every time. Every time, I'm planning to have a second
Okay.
variable really, that it's pretty much going to say where it is coming from. Basically, like I'm gonna have this variable. I would like to call it like it is space or something like that. Like let it could be is space, for example.
Okay.
And this is going to be true once it is in a space. Like once it encounters in space for the first time,
Okay.
or if the one before was in the space. So once this one is true still, right? When this one is true, and my next character is an actual character, then I increment by 1 and turn is a space to false.
You increment
Then
count by 1?
yeah,
Again,
so pretty
sorry.
much like if a space, let me write this a lot better. If it is in a space, right?
Yeah.
If it is in a space, right? And then the next char for the next char, it's an actual character. So we have in this case a space is like is space is set to true. Is a space is true. Is set to true here, let's say. And then my next character, it's an actual character. So it means it's not in a space, pretty much. Then I increment count by 1 and said is a space is a space to false until I encounter another space. That's what I'm kind of
Okay.
thinking.
So the idea is that you have a space variable to keep track of the state to know
Correct.
if it's time
Yeah.
to increment count or not.
Yeah, exactly. Yeah.
And then count is the number of segments that you're returning, right?
And count is the number
Yeah.
of segments that I'm returning. Correct. Yes.
Okay, that sounds like a plan. Why don't you try to code it out?
Sure. Let's and I comment our 1-line solution here. And I'm going to your return count here. So here we return our segments. And then here we loop. So pretty much our loop will really, go over the whole string. It really needs to go through the whole string. So in this case, you could say let char of s, which is just a simple for loop.
Okay.
For char, it's going to be each one of our characters. Then pretty much is a space is actually default to false first because we haven't started counting really.
Okay.
And then so here what I would like to say is if is space, like if it is space, right, it is true. Like we actually want to count only the characters that had either in a space, like whenever space is actually true, pretty much, right? So whenever space is actually true and the next character is a character, then we want we want to count it. In this case, I said our space is actually starts set to false, but for this to work, actually it has to start set to true, because technically our empty or the start of the string, if the first one is a character, we still want it to count.
Yeah.
Right. So technically, like we can start our space set to true. So if a space is a space which is set to true, the first one.
So you're making this condition where you actually gonna count, right?
I'm gonna count. I'm
Yeah.
gonna make my first condition is going to be the positive one, the case that we are starting a new string. If space is space, which is means it comes from space, and and char, which is a character I'm iterating over.
Okay.
It's different to an actual space, really.
Okay.
It's a space is actually going to be the only case scenario where we want to where we want to count. So
Okay.
basically, if it's space and then the next character is different to space, then we count.
Nice.
Now oh, I mean, we count, and of course we said is space to false. And we said space to false.
Okay.
Right. Then the other happy path technically is that of course it could be a character and not be a space. In that case, well, we don't really need to do anything.
Yeah, so again, in this example we see H, so we start a count, right? And then we just look at example 1.
Okay.
H, yeah, so we begin the count and then we keep going until so nothing happens for E, L, L, O, comma, right? And now we hit the space.
Now we hit a space.
Okay. So what we
in the space we don't count, of course. But we said it's space to false. I mean to true again. So we set it back. We set it back to true, right? Okay. And then again, nothing happened till we actually find an actual character, and that's when we count.
Okay.
So in this case, else if, because it is a pretty specific case scenario in which its space is actually false, and like if its space is false, but then it's literally the country out of this one. If its space is false, and then we do find space, which is literally what we set it back here. So we say is a space to false, and now we might have a bunch of other like characters coming in, and then nothing will really happen until we hit an actual space.
Okay.
Whenever we hit a space, pretty much we do the same thing again, where we say it's a space. Now it's going to be true. I guess let me make it a little more visual, because so you can actually see it. We set it back to true, where we find a space, but we don't count really, because again, like we don't need to count because there's no character.
Okay.
Yeah, pretty much.
Okay, so walk through with me this example. So you go to that space and it hits that else if, right?
Right, exactly. So let's say for first example, we start at its space is true, because again, we come from nothing. So if the next one is a space, okay, that's fine. Nothing really happens because its space is already true. But if the first one is a character, then something happens, because our first condition says, oh, its space is true. Okay, fine. Oh, and now the next one is not a space. Okay, let's count.
Okay.
We increment count by 1.
Okay.
And now we said it's space to false because we found a character.
Okay.
Now the one underneath is going to do exactly the contrary, pretty much, like else if. that we were actually going to see it here. Like you'll see that none of this conditions is going to get triggered.
Okay.
Like well, it's gonna get triggered by H because the first one, but then E, as you can see, like again, is a space. In this case, is a space is false. So this is not going to trigger here, and it's not going to trigger either because it's an actual character. It's not a space. E, L is not going to be a space. O is not going to be a space. Again, not going to be a space. But when we find a space, oh, okay, our character is actually equal to a space, but it's a space is actually is false. Then we say, oh, okay, this condition is true.
Okay.
So we said is a space true, but we don't count because we haven't encountered another string really.
Okay. So it just signifies the end of a segment.
It just signifies the end of segment, correct.
Okay. And I keep going.
Yeah.
And then so I guess change to it and then M,
and then again here we find M. Oh, a space is true again. And M is definitely different to a space. So again, we count and we set is space back to false. Yeah.
Okay. Yeah. And we just repeat that process for the entire. Okay. Yeah. So let's test it out.
Yeah, sure. See what we have here. Oh, first one.
Nice.
Should we submit it?
Yeah, let's try.
See what we find. See if we find any corner cases here. Oh, there you go.
Nice, good job. I on your first try.
Yeah, it's
slower, but
it's funny. How is this less efficient than splitting and filtering? I'm going over the array only once. I guess because of the conditionals, but still
there's more info. Yeah, can you go over the time and space complexity for this?
Well, our time complexity would again be O of n because we definitely have to go over every single character.
And then
for our space complexity, this is actually going to be it is actually going to be a constant because we don't really use any extra space. Technically, we do create two variables, but these two variables are going to be the same no matter what. It doesn't matter if we have a million or infinite inputs, it's always going to be an integer and a boolean. So it's going to be all one. And,
nice, good job. You were able to do this on your first try for it. How did it feel?
Feel good and feel fun, as you said, man. Coding interviews can be fun too, and have people have to have in mind that you do use this kind of things in your day-to-day job.
Right.
Maybe not the harder ones, of course, because again, there's a bunch of methods that can do the job for you, but by knowing how to do it, you kind of know how this works underneath. So it's a good thing.
Right. Good job. All right. Thank you, Javier.